Earlier, we have shown how to solve one variable linear equations. Of course, that's a very special class of problems. But it turns out there are many problems are just linear equations in disguise. In this video, we're going to show just two examples to see what's the general idea to approach these kind of problems. So let's look at the first problem. The problem says solve the following equation. 3 over x minus 4 equals 1 over x plus 6. There are in general two approaches we can do this. The first one is realize that if I multiply x to both sides of the equation, you get the following. If I multiply x, this minus 4 equals x times 1 over x plus 6. And this is the same as, we're just using distributive law into this, will equal 3 minus 4x equals 1 plus 6x. And this is a one variable linear equation, and we exactly know how we do it, right? So we're going to with variable into one side, and then the constant onto either side of the equation. So we just do that. So 3, move the 1 to this side, it's become minus 1. And then move the minus 4x to the other side, is going to be 6x plus 4x. This is, of course, we're doing just plus 4x to both sides of the equation. So this leads to 2 equals 10x, and x equals 2 over 10, or 1 over 5. So that's one approach to this problem. The second approach is you realize that this here is 3 times 1 over x minus 4 plus 1 over x plus 6. If we're using a substitution, let y equals 1 over x, then this equation becomes a linear equation in terms of y. And if you can solve the y, clearly 1 over x equals y, so x is just reciprocal of y. So clearly we can just solve it. So let's first do the substitution. 3y minus 4 equals y plus 6. And this is a linear equation in y, and we're going to minus y both sides. You get 3y minus 4 minus y equals y plus 6 minus y. So cancel the y. And 2y minus 4 equals 6. So 2y equals 10, and y equals 5. And now, because y equals 1 over x, that means 1 over x is going to equal y equals 5. And we also get x equals 1 over 5. This idea of substitution to simplify the problem is a very, very important idea. So let's look at another example to see whether we can use this to solve another problem. Okay, this question says, solve the following equation. 2 times square root x plus 1 plus 13 equals 5 times square root x plus 1 plus 7. Now, clearly, this is not a linear equation, right? We have a square root of x plus 1 inside. But here, if you realize there's a square root x plus 1 term, and here is a square root x plus 1 term as well. And there are no other terms with x there. So if you think about a substitution, y equals square root of x plus 1, then this equation will become a linear equation in terms of y, just as in the previous problem. So let's just do that. So this leads to, if we substitute y equals square root of x plus 1, the equation leads to 2y plus 13 equals 5y plus 7. And the idea here is if I can solve the y, then if I know the y, to get the x is pretty easy because we can just square it, and then we get x plus 1 equals a known quantity, and that's basically the idea. So at this point, we're confident as we solve the y, we solve the x. So let's solve the y first. And again, moving the y to one side of the equation, isolation. So we have 2y plus 13 minus 5y equals 5y plus 7 minus 5y. The 5y gets canceled. Here, I combine those together. Minus 3y plus 13 equals 7. And then minus 13 both sides, we get minus 3y equals minus 6. So y is equal 2. And now with the y equal 2, just look at this. We know that 2 is going to equal square root of x plus 1. So x plus 1 is going to equal 4 because we just do square both sides of the equation. It's still an equation, and x equals 3. So here is basically the idea of using substitution to solve equations on the surface does not look like linear equation, but it is really linear equation in disguise.